deficient, and zinc is also getting a very important recognition in our food chain, and that is the reason that we are working on this zinc nutrition, and we want that zinc should that get importance in application, specifically for that as zinc is most deficient in northern India. Zinc deficiency now it is reducing, but in South India zinc deficiency is increasing. And as per the latest report, zinc deficiency in our food chain, approximately 40% Indian soils are deficient. In South India, especially Maharashtra, Karnataka, Tamil Nadu, Kerala, zinc deficiency is increasing. And because that in northern India, we have made that recommendation for the zinc that we should apply zinc continuously, and then we are now because of that recommendation, now zinc deficiency has reduced from 49% to 40%. And similarly, in case of other, that crops, zinc is being supplied by either rice or wheat or maize or pulses or oilseed. Now in northern India, that is a recommendation. But at the same time, why zinc or why biofortification? Because that zinc deficiency is universally. My slides are visible now? Hello?
Yes, sir, it is visible.
Hello? Okay. Okay, thank you very much. So, that it is most deficient in the food chain. That is why we are working on the agronomic biofortification. There are different approaches of biofortification. It is generic biofortification, molecular breeding biofortification, or GM, genetically modified crops biofortification. And at the same time, that agronomic biofortification, it is a complementary approach to enrich the desired, whether it is micronutrient, antioxidant, minerals and vitamins in the economic part of the plant. And that will lead ultimately to increase the production and productivity, and also security of food and nutritional, whether it is in India or whether it is in globally. So that is a concern. But if you see this trends in agriculture and food supply has increased since Green Revolution, energy deficit has fallen, but stable food prices have fallen relatively to nutritious food. Diets are low quality because there is no diversity in the food chain. Earlier, that our forefathers or our predecessors, they were using different like chickpea, pigeon pea, and then that millets they were growing, but they have now vanished from that, specifically from the table of the poor. Poor means those who cannot afford 2 times good quality meal, and they are dependent on the public distribution system. So a dozen of plant and handful of animal species provide 75% of the food. Diets are less diverse as it was earlier, diverse, but we need to make again diverse food, that through the public distribution system. Recently, you may be knowing one gazette notification has been issued by the government of India to include in the public distribution system to the millets, specifically pearl millet, sorghum, maize, and then that minor millets including kodo, sawa, and finger millets. So these definitely will lead to the diversity of the foods, but again there is a problem of climate change, increasing the high carbon dioxide, that is leading to the reducing nutrient content of vegetable food. This is another concern for agriculture scientists working globally and specifically in India, where that that micronutrient deficiency is one of the concerns. Globally, 2.5 billion people are at the risk of micronutrient deficiency, specifically vitamin A, iron, and zinc deficiency. Multi-nutrient deficiency risk and stable the crop consumption. If you see this slide in Asia, Africa, Latin America, and the Caribbean in total, population at the risk, iron, zinc, vitamin A, iron, zinc, and vitamin A. If you see among these three important micronutrients, that is zinc, iron, and vitamin A, among these, zinc deficiency is the largest. That is, it is more than 1.27 billion people are affected because of the zinc deficiency. And why it is so? Because that total calories per millions from the rice, wheat, meat, potato, cassava. These are the important stable food crops in Asia, Africa, Latin America, and Caribbean. And where there is a less diversity of the food, there is more vulnerability to the deficiency of the micronutrient, including zinc deficiency. So micronutrient malnutrition, we can say that people are suffering due to the hidden hunger, and hidden hunger is affecting 1 people out of the 3 people in our country and also globally. And reducing the adult health and productivity, inhibiting children from reaching their full growth and developmental potential. That means that people are suffering, but they are not knowing that they are suffering because of micronutrient deficiency, and it is because of less diversity in the food system, which is major concern because rice and wheat both are inherently low accumulator of the micronutrient, and mostly people now, as per the that food security bill passed by the parliament in April 2013, and since then almost we can say now almost 11 years has gone. So under this food security bill passed by the parliament, 66% people are having the right to get the food through the public distribution system. Since then this food that security bill has been passed. Among these, micronutrient deficiency, zinc deficiency, contributing stunting, lower immunity, increased risk of the diarrhea, disease, and pneumonia. One example of the recently global pandemic where people were suffering because of that corona and still are suffering people. So one of the immunity booster was the zinc tablet or zinc, that supplement to the people suffering from because of that corona. So zinc is really important for that immunity, and it leads to the that overcoming the stunting or lower immunity and reducing the problem of diarrhea or pneumonia if it is being supplemented. If your kid or children being affected because of diarrhea, have you seen what doctor prescribed the tablet? One of the tablet is there, that zinc tablet. It is because of it is involved in the the immunity booster. And people, those who are having the less diversity in the food chain, they are suffering more. So globally, 1.7% of total deaths among children less than 5 years. That means 116,000 attributable deaths annually, and this has been published in Lancet. Lancet is a that high impact factor journal, 20 NAS rating. That where medical articles are being published. And Black and his associate, they have published in 2013. And 155 million children less than 5 years globally suffer from the stunted growth. As per the report of Food and Agriculture Organization 2017, the global burden of zinc deficiency curtails social development. About 28 million disability adjusted years, dailies, disability adjusted life years, that means that are annually lost as per the report of Caulfield and Black, WHO, World Health Organization. And what is the impact on the economic loss globally? The economic cost, that is 1 daily is equal to the US dollar of 1,000, and it that lead to that it lead annually to the loss of US dollar 28 billion annually. It is a huge that loss because of that zinc deficiency globally. So you can think of that, how much it is important, zinc is important. That a vicious cycle of poverty, that means a malnourished children with stunted brain and a healthy, well-nourished children, that means the children having a diversity in the food, or they are getting supplements by, that those who can afford tablets or that enriched food and that fortified food. So their brain is well off, whereas it is that under malnourished brain is stunted and its growth is not as it should have been for the productive mind. So this report came by the World Bank 2018, and it clearly indicates that poverty is one of the important reasons where people cannot afford diversity of food, and they are solely dependent on the rice and wheat, and they are not having diversity in the food chain. So after seeing the problem of the zinc deficiency, what are the that strategies by which we can that overcome the hidden hunger, specifically the zinc deficiency? So one important that strategy, four-pronged strategy is dietary diversification. That means we should have diversity at the table: milk product, meat, fish, dal, vegetables, and of course little amount of rice and wheat, whether chapati or rice cooked. Then supplementation is one of the important program of the government of India, where that iron supplements are being given for the lactating that women and pregnant women, but it is not as successful as it would have been successful. But of course it is one of the that strategy out of the four-pronged strategy which can overcome the hidden hunger of micronutrient deficiency. Then fortification. Recently, Government of India has issued a notification or gazette for fortification of the iron in the rice, and some of the 300 rice mills, they have made a provision of machinery for fortification of iron in the rice, and that will be supplied on the pilot basis in 100 sticks. That after fortification for overcoming the iron deficiency, those who are dependent on the rice. Then biofortification. Biofortification, that these are the short-term approaches, but biofortification is a long-term approach, and then that it can overcome specifically those who cannot afford the dietary diversity, supplementation and fortification. But biofortification, when it comes in the plant system, or when it comes in the assimilation of the plant system, that means they are having the higher amount of antioxidant, micronutrient and minerals. So that will that will supply to the desired micronutrient for the that stakeholder. Stakeholder means consumers. If you see this boy which is having a very that high amount of micronutrient are added through this rice, because that they are in a rice is inherently low accumulator of the micronutrient, especially iron and zinc. So billions of people around the world suffer from the hidden hunger of micronutrient malnutrition. Poor people diets in developing countries consist of high amount of stable food such as rice, wheat, maize, but few micronutrient rich food like fruits, vegetables, animal and fish products are there. And that is the reason that those who are mostly dependent on rice and little bit, dal and maybe vegetable, they are more vulnerable to the micronutrient, especially zinc and iron. So more than 4 lakh children die each year due to zinc deficiency in our country. This is a matter of concern. So zinc is really essential mineral elements in the food chain. It plays vital role for the proper immune system functioning and crucial for healthy growth and physical and mental developmental of the children. So this is very, very important to increase the boosting immunity. India has one of the highest level of zinc deficiency in the children, and it is because of in our soil zinc is deficient, and when we grow a plant in the soil, that means they are not accumulating as high amount as other, that pulses and oilseeds they accumulate. Zinc fertilizer zinc fertilizer not only improve the food production but also ensure the nutrition security. This is the reason that we are working on the agronomic biofortification through application of fertilizer, or specifically zinc fertilizer, intercropping, mixed cropping, and bioconsortia, cyanobacterial formulations, that biofilms we are using as one of the important strategies for increasing the zinc nutrition. And moreover, recently, zinc nutrient initiative has been started by the, that International Zinc Association. It is a good sign to overcome the zinc deficiency. As per the World Bank report, nearly half of the Indian children, nearly 41 million under the 5 years are stunted. This represents 34% of all stunted children globally. And this has been reported by two scientists, Black and his associate 2008 latestly. I'm not just, giving some data, but I am just apprising you, that how much serious problem is there, zinc deficiency in our food chain. Another important area is climate change. And climate change, that how can we define climate change? Over the base, more than 30 years data, when there is a change in the carbon dioxide, temperature, humidity, and any other things that comes under the umbrella of the climate change parameters. So carbon dioxide, as you know, that presently 410 ppm carbon dioxide is there in the environment. But we are expecting 2050 or even before that, there will be 550 ppm carbon dioxide in the environment. And why rising carbon dioxide level are bad for Indians? It is making stable rice and wheat less nutritious, putting millions of risk of malnourished. This is one of the study carried out, that by the T.H. Chen public school in the US. Millions of Indians are at the risk of becoming nutrient deficient by 2050, as rising level of carbon dioxide are making stable food crops such as rice and wheat less nutritious, according to the study. Researchers at Harvard T.H. Chen School of Public Health in the US found that rising carbon dioxide level from the human activity because of, that industrialization and more carbon dioxide release into the environment, resulting into 175 million people worldwide becoming zinc deficient and 122 million people becoming protein deficient by the middle of this century. That means 2050, definitely there will be a serious problem. The study published in Nature Climate, it is a high impact factor journal, Nature Climate, having an R rating of 20, found that 1 billion women and children could lose to a large amount of their dietary iron intake, putting them at increased risk of the anemia and other diseases. And it was also found that India should bear the greatest burden with it. India will have the maximum population suffering because of, that zinc deficiency. And it may be around 50 million people in the, in our country in 2050. This is a huge amount of population which will be suffering because of zinc deficiency. And as many as 30 million people in India are at the risk of becoming protein deficient, and 502 million women and children becoming vulnerable to the diseases associated with the iron deficiency, zinc deficiency, as per the reports. Other countries in South Asia, or that Southeast Asia, Africa, West Asia would also be significantly impacted. Why? Because that their research, it clearly tells that how we are living these days. Our homes are being heated during the winter season, during the summer season. Now everybody is running or sitting in the AC room. So that means that somewhere we are leaving the more carbon dioxide, more methane gas, more that CFC into the environment, and somehow this is leading to the global climate change, and it is making less nutritious food. As per the report of principal, that research scientist at the Harvard Chen School, Sam Mayers, and humans tend to get a majority of the key nutrient from the plant. 63% of the diet protein comes from the vegetal sources, that is our vegetables, cereals, pulses, oilseeds. and as well as 81% of iron and 68% of zinc, as per the report published in climate change, nature climate change. It has been shown that high atmospheric level of carbon dioxide results in less nutritious crop yield as per the reports. So concentration of protein, iron, zinc are 3 to 17% lower when crops are grown in environment where carbon dioxide concentration are 550 ppm. That means presently we are having 410 plus minus 1 plus minus 2 ppm. But at the same time, it is expected to increase 550 ppm under the current atmospheric condition. It is 400. Earlier it was 400, but now it is 410. So when it will reach 550, it is expected 2050. That means our, protein accumulation, iron accumulation, and zinc accumulation will be less in our rice and wheat. And this will, have the global impact on the burden of carbon dioxide related nutrient shift in the crops in 151 countries. So the study show that to the middle of this century, when atmospheric carbon dioxide concentration are expected to reach around 550 ppm, 1.9% of the global population, roughly 175 million people based on 2050 population estimate, could become zinc deficient. So right now we are having 40% zinc deficiency, 39% as per the latest report of Dr. Arvind Shukla, project coordinator of micronutrient and heavy metal, located in the Indian Institute of Soil Science, Bhopal. But it will have aggravated, it will be aggravated in the times to come, or up to 2050. About 1.3% of the global population, or 122 million people, could become protein deficient. I don't know, because nitrogen and zinc, they are having a positive correlation. So protein deficiency, those who are having, that specifically less nutritious food, and that less nitrogen application in some crops, so that lead to the low level of the protein accumulation in different crops. So additionally, 1.4 billion people of children bearing age under 5 age who are currently at the high risk of iron would have their dietary iron intake reduces 4%. So researchers also emphasize that billions of people currently living with nutritional deficiency would likely see their conditions were worsen, or that problem will aggravate in the times to come because they will be getting less nutritious food. So zinc in the human nutrition, after seeing the zinc deficiency and its importance in our food chain, then human, zinc deficiency. Zinc deficiency in human first time was, first time Dr. Anand Singh Prasad, A.S. Prasad, in 1961-63. He described the first case of human deficiency syndrome. He was from Bihar. He was posted in that Egypt and Iran under the program of WHO, and he first time that described the zinc deficiency. And since then, zinc deficiency, that it is a highly researchable issue in the human nutrition as well as in soil. So need of zinc in human nutrition was brought by the Prasad 1984, but long back 61-63, first time he, that shown the deficiency syndrome of zinc. And what was the reason who reported that zinc deficiency was responsible for dwarfism, that is stunted growth, delayed sexual development, hypogonadism among adolescents from the lowest social classes in Egypt and Iran. Adverse effect of the zinc deficiency in humans vary with age and include low weight gain, diarrhea, pneumonia in infants, dwarfing among toddlers, school children, and taste sensitivity. And that loss of the test was one of the important, that indicator in the people suffering from the corona. So that means it was long back identified that zinc is essential for the test sensitivity, and then chronic non-healing ulcers, recurring infections, eyesight problems among the elder. So these are the important, that indicators in the human health of the zinc. And long back in 1961, Anand Singh Prasad, A.S. Prasad, first time discovered the zinc deficiency in the food chain, or specifically in the human health. You must read this paper, A.S. Prasad, 1984, Discovery and Importance of Zinc in the Human Nutrition. Federation Proceedings, published in 43 volume, and page number 2829 to 2834. Another article, Zinc Deficiency in Humans and Neglected Problem, Journal of American College Nutrition. So these are the two important classical, article published on human nutrition. So what are the reasons for the zinc deficiency? High consumption of cereal-based food with low zinc concentration. In rural areas of India, rice, wheat contribute nearly 75% of calorie intake through wheat or rice, and this is the reason. The cereals and human nutrition. Cereals are major source of energy to rural people. Rice and wheat most important in food chain. Zinc deficiency in polished rice is hardly 8 to 14 milligram per kg. That means 8 to 14 ppm or milligram per kg in the white rice kernel. This is the content in the white rice kernel, not the brown rice. Brown rice may contain up to 20 to 24 ppm or milligram. In wheat, it varies from 15 to 45, even 50 milligram per kg. In maize and zinc content is far less as compared to the wheat, though it is not a stable food crop. Ista and wheat quality is also equally important in our food chain, because our problem is not to feed 132 crore people or 1.32 billion people in India with less than 2.5% land globally and less than 4% of water resources globally. And our population of animal or bovine, it is, 536.78 million as per the bovine or cattle population census 2019. So every 2 human is having 1 animal. So for us, it is not only grain, but also extra is equally important in the food chain. For better zinc nutrition of human beings, cereal grains should contain around 40 to 60 milligram per kg. But the current situation is irrespective of, that rice and wheat, 10 to 30 milligram per kg. And we want to increase it 40 to 60 milligram per kg to overcome the zinc deficiency. Then let me define the biofortification. Biofortification is a process of increasing the density of vitamins, minerals in a crop through plant breeding. Plant breeding may be a molecular breeding, allele or gene mining, or maybe a genetically modified approach, or agronomic approaches. Agronomic approaches including biofertilizer application or fertilizer application, time of application, method of application, soil application, foliar application, seed coating, so that the biofortified crops, when consumed regularly, will generate measurable means that can be measured that can be estimated in the improvement in the vitamins and mineral nutritional status. So that means it is an approach where we are targeting to increase the desired micronutrient or vitamins and minerals or antioxidants to increase their concentration in any crop, whether it is cereal, pulses, oilseed, or maybe that vegetables. So our target is to increase the desired quantity of minerals or minerals or micronutrients and antioxidants. Then biofortification can be of different approaches, can be divided like conventional approach, which include agronomic approach, breeding approach through that traditional breeding, not genetically modified or biotechnological approach. Biotechnological approaches are another molecular marker, genetic engineering, and including GM biofortified, genetically modified crops. So agronomic approaches for biofortification, broadly we can include, that adequate fertilization, method of application or method of fertilization, time of application, farmyard manure. That means farmyard manure is one of the important component for integrated nutrient management, which contain micronutrient as well as the NPK, sulfur, calcium, magnesium. Then crop rotations are also equally important for agronomic biofortification. When we are having a crop rotation of deep rooted followed by that shallow rooted, or maybe that mung bean followed by cereal, or chickpea followed by cereal, or maybe pigeon pea followed by cereal. So that means the crop rotation also play important role. Then intercropping wheat plus chickpea. This is a classic example reported from that China. A lot of papers has been published from China where they have shown that intercropping of chickpea plus wheat or wheat plus chickpea, they are having a complementary effect because of root exudation and root rhizosphere environment for making the micronutrient more available for absorption and translocation in the plant system when they are grown in together. So therefore, we can say that when we are applying fertilizer to the seed, soil or foliage at greater or higher rate than those required for maximum yield to increase the uptake of micronutrient in the plant and in translocation into the seed, that comes under the umbrella of agronomic biofortification. Then zinc agronomic biofortification of food grains for our means right source of nutrient stewardship. That is source may be of for zinc sulfate, zinc oxide, chelated zinc, organic manure, green manuring, zincated urea, and then now we are having nano zinc oxide, or that nano zinc engineered zinc oxide material for as a source of zinc. Then rate in crops and cropping system, because when we are targeting only crop, the approach may be different, or level of application or dose of application may be different. But when we are targeting as a cropping system, rice wheat cropping system, maize wheat cropping system, mung wheat cropping system, then rate will be vary. Then time may be seed priming at sowing, transplanting and grain filling. So this is that another important consideration for agronomic biofortification, because seed priming these days getting momentum for specifically seed coating and dipping of that that seed into the zinc solution and dipping the seedlings of rice when we are going for transplanting. So this is another important. Then method, soil application, foliar application or conditioning. So these are the different that approaches of agronomic biofortification. Sources of zinc application. If you buy any zinc sulfate 10 kg bag, that, and if you apply after opening the bag some 4 or 5 kg and remaining amount get lump formation, and it becomes lump. It is not uniformly distributed and it is very difficult to apply uniformly. We need to crush it again because hydration is the problem. Release of the water during the storage of the zinc sulfate. So we have done some work. That means we have done that conditioning of zinc sulfate with zinc oxide and neem oil. What we have done, we have taken 94 gram of zinc sulfate, 2 gram of zinc oxide, 4 gram of neem oil, and we have conditioned it. And then we have also developed, this is drilled urea, and this is that 0.5% zinc coated urea, and this is 1% zinc coated urea. So these products we have developed in our own laboratory, and we have tested for different crops and cropping systems. One of the study of agronomic biofortification was published in European Journal of Agronomy in 2012 by one of my PhD students, Dr. Vijay Punia. Now he is my colleague as a senior scientist, where he has shown that 2% zinc and urea through zinc sulfate has improved the grain yield, zinc concentration in the grain, and also zinc concentration in ester. And of course, the foliar application, 0.5% zinc sulfate as better as compared to the that other level of other method of zinc application, like 2% zinc and urea through zinc oxide or soil application through zinc oxide and zinc sulfate and slurry, So foliar application, because it enters into the direct plant system and it comes into the, the plant system. So its recovery efficiency is high, and that is why he has recorded higher concentration because of foliar application as compared to the soil application of, zinc sulfate or zinc oxide in grain extra as well as grain. It is not only basmati rice or aromatic rice, but we have also one of my PhD student, again Shankar Lal, that is now my colleague in the Indian Institute of Maize Research. He did, that experiment involving dual-purpose summer grain legumes and zinc fertilization for improving the productivity and zinc utilization in hybrid rice, where he has shown that approximately 6 milligram zinc was increased in the, that aromatic hybrid rice, that is PRS10, with 2% zinc enriched urea through zinc sulfate. And that it was significantly better than other method of zinc application. And these were the, material which we have used for this study. It is not only fertilizer, but also if you include the dual-purpose summer grain legume for increasing the zinc concentration in hybrid rice, it works. And if you see summer fallow and then mung bean and then cowpea, so there is a significant increase in the zinc concentration in the, that hybrid rice, aromatic hybrid rice, as compared to the summer fallow, where we are seeing approximately 2 milligram zinc concentration increase because of that mung bean and cowpea residue incorporation after picking of pod, that for seed and for seed purpose. And that approximately here 10 milligram, 10 to 11 milligram zinc concentration was increased in the extra of paddy. Another study which we have published in Proceeding of the National Academy of Sciences, Allahabad Biological Sciences, where we have shown that we have taken, the two sources, that is zinc sulfate heptahidrate and chelated zinc, that is zinc EDTA, and we have taken 2% foliar, 0.2% foliar spray, 0.5% foliar spray at 3 stages, and we found that between these two sources, EDTA zinc was better in increasing the zinc concentration in the rice grain as well as in rice straw, and soil application was not as better as the foliar feeding. And again, that if you take a case of soil application through zinc sulfate and soil application through zinc, soil application through EDTA, zinc EDTA. So zinc EDTA was better than this. If you see, zinc sulfate was accumulated 26.9 milligram, but here soil application through EDTA, almost I can say 2 milligram increase was there because of EDTA, because its efficacy is more as compared to the zinc sulfate. So sources also play a very important role in increasing the zinc concentration in the economic part. The rate of zinc application, we have tested zinc sulfate and zinc oxide enriched urea from 0.5% to the, that 2% zinc enriched urea. This is 0.5% zinc enriched urea through, that zinc oxide. This is zinc sulfate, another, this is zinc oxide, this is zinc sulfate. So we have taken these, that levels for levels of zinc enrichment, and we found that there was successive increase in the zinc concentration in the grain as well as in the rice straw. However, straw contain more as compared to the rice grain. Then another study we have seen, that relative efficiency of zinc oxide and zinc sulfate enriched urea for spring wheat. Because in India we are growing spring wheat, we are not growing, that winter wheat. Winter wheat need a, that chilling treatment specifically when we are, that in European countries, Canada, Australia, Russia, they are growing winter wheat in some areas, Australia but not all. So there is a winter wheat, but we are growing spring wheat because there is no rain there is no snowfall, and then you know that we have taken different enrichment of 0.5% to 2% zinc enrichment through zinc sulfate and zinc oxide, and it was observed that approximately we can say that 11 milligram zinc, 11 to 12 milligram zinc increase was there because of 2% zinc sulfate enriched urea in the grain, and in ISTA also almost 10 milligram. For your kind information, and please make a note of it, zinc concentration in grain is always more in case of wheat, but zinc concentration in grain is always less in case of rice, and similarly reverse case is the ISTA. ISTA less concentration in wheat and higher concentration in the rice. Those who are working or those who want to work on that zinc nutrition in rice and wheat crop, they should take a note of it. And recovery efficiency was highest of zinc with 0.5% zinc enriched urea, which is obvious because with the low level of application, recovery efficiency is higher. But the beauty of this, you know, that zinc enriched urea application in rice and wheat, because we are applying only 2 kg zinc or 2.6 kg zinc, it is a significant reduction in the quantity of zinc application. When we are applying, you know, the recommendation is 5 kg zinc through 25 kg of zinc sulfate. Just we are adding half amount of zinc through zinc sulfate. So that means we are not adding more and more quantity, but we are trying to make it, because both the elements zinc and nitrogen, they are having complementary to each other, and at the same time we can increase the recovery efficiency when we are applying zinc enriched urea for agronomic biofortification. Another trial we have conducted to see the response of zinc application to the chickpea, and we found in increasing the zinc concentration when we apply the zinc level ranging from 2.5 to 7.5 kilogram per hectare. There was significant increase in the zinc concentration. Almost 11 milligram per kg zinc was increased in the grain, and you know that almost 12 milligram zinc increase in the straw of the chickpea. And then time of application, this experiment we have conducted again in chickpea and published in Communication in Soil Science and Plant Agriculture, where we have shown that if we are, you know, that applying at different growth stages like soil application, vegetative growth, vegetative plus flowering, vegetative plus grain filling, 3-foliar application through zinc sulfate, and 3-foliar application with the zinc EDTA. So zinc EDTA was much better to increase the zinc concentration in the chickpea grain as well as in ISTA. 53% increase have been seen because of 3-foliar feeding of the zinc EDTA at vegetative flowering and grain filling, and 90.6% increase in the ISTA. Zinc concentration was increased. So this is a very important finding, those who are interested to agronomic biofortification. Then time of application zinc in chickpea, it is not only increasing the zinc concentration and productivity, but also lead to that agronomic efficiency and crop recovery efficiency, where we have shown that EDTA zinc applied a 2-foliar spray, that is vegetative and flowering, maximum agronomic efficiency was recorded. And in case of you know that spray, recovery efficiency was higher. It is because of less addition of the, you know, that zinc through EDTA. 1 second. हाँ मैं क्लास में अभी थोड़ी देर में बात करता हूँ. नहीं, वो नाइट्रिक एसिड भिजवा रही हूँ आपके पास. ठीक है, भिजवा दीजिए. थैंक यू. आपका रूम नंबर बता दीजिए. रूम नंबर 24. Okay, thank you. Thank you. Sorry for the interruption. Are you on the platform or are you sleeping? Hello?
Yes. We are listening you, sir.
Hello, sir. We are getting you properly.
Okay, thank you. So, Thank you, thanks a lot. So, you know that foliar feeding is always better, specifically for agronomic biofortification and as well as agronomic efficiency. That means increasing in the grain per kg of nutrient applied and also recovery efficiency, which we have shown through this experiment. Then we have also done work on agronomic biofortification of oat grain through zinc fertilization. That we have published in Agriculture Research Journal of NAS, where we have seen, you know, that oat now these days is important, specifically those who are suffering from cholesterol or bad cholesterol. So, you know, that doctors are prescribing that oats as a one of corn, prescribing flax, especially breakfast time. So it is getting important, specifically supermarket departmental stores. So considering its importance in the food chain, we thought let us also work on this crop, which is not the mandate crop of ICAR-IARI, but as an agronomic biofortification, let us try. And we tried, you know, that different methods of zinc application, like 2 kg zinc as a zinc sulfate deep placed the soil, 2 kg zinc per hectare zinc sulfate used for coating of seed onto 100 kg seed required for sowing 1 hectare. And then 5 kg zinc per hectare zinc sulfate as broadcast at sowing, and 5 kg zinc through, you know, that zinc sulfate band placed before first irrigation, 25 days after sowing. 5 kg zinc per hectare zinc sulfate band placed before after first irrigation. Among all these methods, what we, you know, that got the better response with the seed coating. Seed coating with 2 kg zinc through zinc sulfate onto 100 kg seed, which is required for sowing 1 hectare for oats. And it increased approximately, you know, the 40% zinc concentration in the grain, and agronomic efficiency as high as 428 kilogram grain increase per kg of zinc. And net returns also 58,411, and crop recovery efficiency of zinc was as high as 17.7%. That means it is, you know, that soil application generally we are getting a very less, but specifically in foliar, in seed coating in this case, we got a very good response to the crop recovery efficiency. The method of zinc application is also equally important. We have published this article in Egyptian Journal of Biology. Unfortunately, this journal has stopped now. They are not publishing. It is our bad luck that we have published one of our article in that journal, which is now stopped for, you know, that publication of the article. And we have done in the, you know, that corn. Corn is again an important crop for in our food chain. Now it is not only important for making chapati, but corn flax, and also, you know, that poultry feed industry and that animal feed industry, and then starch extraction. So it is a very important crop. In this, we have taken soil application, foliar application, soil plus foliar application, and we found, you know, that 2.83 kg zinc to zinc coated urea, and we found that soil plus foliar application was better in case of corn for increasing the zinc concentration in grain as well as stover, and also agronomic efficiency was higher with the foliar application, which is obvious because here we have applied only 1 kg zinc, whereas in other cases we have applied higher amount, and recovery efficiency 15.27%. Then, you know, that we have done some conditioning of the zinc sulfate, considering, you know, that zinc oxide neem oil conditioning for improving the quality of micronutrient zinc fertilizer heptahydrate. I.K. Suri was retired mechanical engineer from NFL, and we have published this article in Current Science in 2011. And as per the, you know, that Government of India Fertilizer Control Order 1985, zinc sulfate should be free from flowing, contain 21% zinc, and should have a pH more than or equal to 4. So you know that, however, zinc sulfate marketed in the India had the following drawbacks. What are the drawbacks? Like lump formation during storage, a lack of free flowing, the presence of free acidity, that injurious seedling. Maybe if you know that this lump is, one lump is placed near to the seed somewhere, so it will have the injurious to the seedling. So we have done some work. We have taken, that zinc sulfate and conditions with the neem oil and published in current science. And then not only published in current science, but also have seen its efficacy in rice to see the extra concentration and zinc concentration. Because of that effect of zinc sulfate heptahydrate conditioning with zinc oxide and neem oil on growth, productivity, zinc concentration, biofortification of zinc and zinc uptake by aromatic rice or basmati rice, which we have published in Journal of Plant Nutrition. And it has been reported that there was significant increase in the, that extra concentration with this, specifically 2 kg zinc per hectare with zinc oxide, that neem oil, zinc sulfate, and 2 foliar spray. And similarly, we also got the higher zinc concentration in the grain. So that means, that if we are using conditioning of, that zinc sulfate with the zinc oxide and neem oil, its efficacy is increased and we are getting better response in accumulation and assimilation in the plant system. Then zinc sulfate heptahydrate conditioning effect on crop recovery efficiency and agronomic efficiency. And we found that, significantly increase in the agronomic efficiency. That means kilogram increase per kg of zinc applied and crop recovery efficiency. And it was as high as 14, more than 14. And also agronomic efficiency, approximately 270 kilogram grain increase per kg of, that neem oil, zinc oxide conditioned with the zinc sulfate when we are going for foliar spray, not the soil application. Recovery efficiency and agronomic efficiency, because we have added less and recovery efficiency was more. Then we have also done some to see the genotypic differences in the zinc response to the, that all varieties are not the same for, that response to the zinc, they are responding differently. Where we have done one experiment and published in International Journal of Bioresource and Stress Management. We have taken 3 varieties of chickpea, that is Pusa 2024, that is Kavli, and 2 other rest varieties were Desi, Pusa 5028, Pusa 372, and we found that Pusa 372 was better zinc accumulator as compared to the 2 other varieties. And if we compare this, that Desi variety, Kavli variety contains more less zinc in the grain as well as extra as compared to the Desi variety. And also another article we have published in Journal of Plant Nutrition, where we have seen, that different rice varieties are responding differently to the zinc concentration assimilated in the, that in the dry matter, in the rough rice concentration and agronomic efficiency. So we have seen that among the tested variety, Pusa Basmati 1, Pusa 72, Pusa 73, Pusa 74, Pusa 75. This Pusa 73 was better accumulator of the zinc in the dry matter. And for the agronomic efficiency, Pusa 72 was better. But unfortunately, these 2 varieties are no more in the public domain because these varieties have been rejected by the, that farmers because of some disease problem. But bidders, their stock are there, that parental lines they are using for further improvement. Another published article in that Indian Journal of Plant Physiology, one of my students, Dr. Prakash Chandra, he has taken 5-6 varieties like Pusa Basmati 1401, Pusa Basmati 1460, PRS 10, Pusa Basmati 1121, that is, that Pusa Sugandh 5 also, it is known as Pusa Sugandh 5. Then Pusa Basmati 1509, Pusa Sugandh 5, Pusa Sugandh 5. I think it is Pusa Sugandh 4. I'm not sure. but it is the longest grain variety Pusa Basmati 1121, which is having $200 US premium in the international market because of its longest grain. Where he has shown white rice kernel, what we are eating, it is containing 20% zinc, 31%, 29%, 30%, 27 white rice kernel, and 33%. And rest of the, that zinc in the paddy remains either in the bran or hull, as high as 64%, as high as 50% in hull, as high as 40% in hull, as high as 48% in hull, 53% hull, 39% hull. So different varieties, they are having the different, that accumulation in different parts of the grain of the paddy. But the major concern is those who are eating white rice kernel, polished rice, they are consuming less micronutrient and specifically zinc. Those who are eating, that brown rice without polished, they can consume that more because bran, that the coming zinc in the bran that can retain in the brown rice. So it is one of the recommendations from our study. Rather than eating the white rice kernel, people should eat, that brown rice to overcome the zinc deficiency or other micronutrient deficiency. I would now like to summarize my talk. Agronomic and human nutritional benefit resulting from the use of zinc and its seeds that comes through the genetic biofortification or agronomic biofortification. It increase the disease resistance and decrease the seedling rate, and then also higher yield under zinc deficiency, improving abiotic stress tolerance, better seed viability and seedling vigor, and ultimately it is leading to the improving human nutrition, which is a major concern. So conclusion and recommendations, agronomic approaches such as, that application of zinc containing fertilizers in soil through foliar, inclusion of dual-purpose summer green legumes in rice wheat rotation, or maize wheat rotation, or cotton wheat rotation, selection of zinc efficient cultivars of rice and wheat can provide a rapid and simple solution to the zinc deficiency. That agronomic biofortification, besides increasing the yield, agronomic approach, that lead to the enrich in the cereal grain of zinc, not only in grain but also extra, which will alleviate the zinc deficiency from the food chain. And use of zincated fertilizers need to be promoted, particularly under cereal-based intensive cropping system, where nitrogen and zinc are most deficient, and both need to be, that adequately addressed through zinc and its urea. Combination of breeding and strategy is an excellent complementary approach to alleviate the zinc deficiency related to human problem in the human nutrition. And that we are not agronomic biofortification, we are not competing with the breeding approach, but we are complementary. That we have seen, and we are going to get a published very soon one article where we have shown that breeders, those who have released in the name of biofortified variety DRR 45 from the Hyderabad, where they have shown that 22 ppm or milligram zinc is there. But in our conditions, that it did not respond to the zinc application. But other non-biofortified varieties, they have responded to the zinc application. So agronomic biofortification is a complementary approach where we are using method of zinc application. I would not like to discuss. This is my citation. It is more than 6,000. Today it was 6,117. H index 40 and I-10 index 139. And future line of research work considering the benefit. So it need to be, zincated urea need to be promoted beyond rice and wheat, and more thrust should be given on the development of zinc efficient cultivars, particularly for areas or soils or regions where crops which face severe zinc deficiency. And multidisciplinary team involving plant breeders, soil scientists, plant physiologists, agronomists, and even human nutritionists and animal nutritionists, they should work in tandem to tackle the problem of zinc deficiency from the food chain. So these are the that another area we have future line of research will need to be promoted, and in isolation we should not work. We should work in the team, and in teamwork we get more. Everyone we get more benefited, whether it is publication, whether it is recognition. So working in isolation is not good always now. We need to promote that multidisciplinary approach involving different disciplines. I think with this I have completed whatever I wanted you. Thank you very much for your kind attention. I will be happy if you have some questions and clarification based on my presentation. And if you don't ask any questions, I will feel that I have not, communicated properly to you about the agronomic biofortification.
Thank you very much, sir. I think one of the faculty, Ashish Dwivedi ji, wants to ask something. Ashish, please open your mic and ask your question.
Yes, sir. Good afternoon, sir. Sir, I would like to ask a question. Sir, how to do fortification of organic agriculture component like compost, vermicompost, biofertilizer, bioherbicide, and biopesticide?
So it is a very important question. You know that we can go for fortification of the vermicompost, or you know that FYM and biopesticide. Biopesticide, I may not be sure, because biopesticide are, you know, that extractant of the botanicals, or maybe produced by the fungi, or actinomycete of bacteria, cyanobacteria formulations. But for FYM vermicompost, we can definitely enrich through, you know, that rock phosphate directly mined, not treated. So we can enrich through rock phosphate, which is and we can even also enrich through the rocks and minerals floors. Rock and minerals floors after grinding, that can be, you know, that enriched in the FYM. So this is another area where I have published in Plant and Soil one of basic work conducted during my 10 months stay in Norway, where I collected the, you know, the leachate in the incubation studies from the rocks and minerals, mineralization of micronutrients from rocks and minerals, sensitive waste compost, which can be used in the organic production system. Because we have just started organic production in our country or natural farming, but European countries since long back they are working on the organic farming, and now they are facing micronutrient deficiency. In 2003-04, during my 10-month stay, they gave me assignment to identify the rocks and minerals floors, which is, you know, that can be used as a source of minerals in the organic production system, so that we can enrich our grown crops under the deficient of the micronutrient. So definitely, without, you know, that treating rock phosphate and gypsum, without treating, can be enriched in the rocks and minerals, which contains the higher amount of micronutrient that can be enriched in the FYM vermicompost for overcoming the micronutrient deficiency in the organic production system. And moreover, if you know that have a green manuring, or you have intercropping and under organic production system, and these are the important component of organic production system. Without diversity maintaining in the farms, we cannot advocate organic or natural farming. We have to have, you know, that green manuring. We have to have use solubilizers, mobilizers, biofertilizers, which can make the nutrient available to the organic production system. And now there are zinc solubilizers available, and that have been patented by, you know, that I know Krida long back they have patented this one of the biofertilizer, bacteria, fungi, actinomycete, consortia, which they are using for the as a zinc solubilizer. Our division of microbiology, they have also worked on this aspect, and they are also having now zinc solubilizers, mobilizers. So under organic production system, there are different approaches where we can overcome the micronutrient deficiency, and we can get the better harvest or zinc enriched or micronutrient enriched produced, harvested from the organic production system.
So thank you. If anyone else wants to add something?
Sir, I have
Would you
one
like to
other
add
question.
something? Okay, okay.
Ji,
Please go
sir.
ahead.
Sir, is biofortification of biofertilizer possible?
Yes, of course, it is possible, and now we are working on this with the microbiology division. As one of the, the treatment we have taken foliar application and as well as seed priming of the biofertilizer to enrich our economic part of the plant. Definitely it is possible, and some publications I am seeing in the public domain published some of the groups from the Pakistan, from India, and from other countries also, as well from China. I am finding now even foliar application of liquid biofertilizers can enrich the micronutrient, because it that helps specifically when we are going for seed priming and foliar application. It is secreting more phytohormones, that is that making nutrient in the root rhizosphere more available from unavailable source to the soluble form, and thereby more absorption and translocation and assimilation in the plant system.
Thank you, sir. Thank you so much.
Okay, if anyone else wants to ask something, then he or she can raise a question. Otherwise, you can write us to the WhatsApp group, and we will try to extend your queries to the expert, and we will get a solution for you. So thank you very much.